In this video, I'm going to explain what the hell are radians. How do you use them? Why do you use them? Where did they spawn in from? Okay, to work out what the hell a radian even is, I'm going to start off by asking you a simple question. What is the circumference of this circle on my screen? The formula for the circumference of any circle is equal to 2 times pi times the radius of that circle. And as you can see here, this circle has the radius of 1. So that means it's a unit circle. So the circumference is simply equal to 2 pi. 2 pi units. That's going to come in handy to explain what the hell a radian is. I'm going to ask you another question. If I were to ask you, what is this angle that I have drawn on my screen? What angle would you say that is? If you said anything but 90 degrees, I would highly recommend you redo all of trigonometry. But in this case, it's 90 degrees. But the question I really want to ask you is, how much of the circle's circumference does this 90 degrees cover? What is this arc length? What is the length of the arc of this circle inside the 90 degrees? Well, by just looking at it, you can tell it's a quarter the arc of the entire circle. It's a quarter of it. And you know the arc or the circumference of the entire circle is simply 2 pi. So that means the length of this arc in red is simply a quarter of 2 pi. And that is equal to pi over 2. In other words, rather than having to tell me what is 90 degrees, you can simply tell me this length as well. That is what a radian is. Okay, this is what a radian is. This is how you define radians. In other words, 90 degrees is the same thing as pi on 2 radians. Let me ask you another question. We'll do the exact same problem. This time, I'm going to do a different scenario. This time, rather than doing 90 degrees, I'm going to ask you, what about this area, this region here? So I'm going to say this angle here is 60 degrees. Okay, well, I really care about this angle here. Tell me, what is that angle in degrees and radians? Let's work it out together. Well, what I can recognize is, first off, if that angle here is 60 degrees, and this entire angle here is 180, theta must be 180 minus 60. So that makes theta simply equal to 120 degrees. Now the question I have for you is, how much of my circle circumference is bound inside of this 120 degrees? Well, the way you work that out is you recognize this is 120th of 360 degrees. This entire arc here is 120 over 360, the entire circumference. In other words, it's a third of the entire circumference. If we know the entire circumference is 2 pi, then the length of this arc is simply 2 pi divided by 3. Okay, another way of saying that is 2 pi times by 120 divided by 360, because we're doing it as like a percentage, it's a fraction. Okay, so this is equal to 2 pi on 3. What else is equal to 2 pi on 3? 120 degrees. Okay, this is what a radian is. Instead of working out arbitrarily 90 degrees is this, ever wonder where 90 degrees came from? Yeah, it's pretty arbitrary, I'm not going to lie. But now instead of doing that, we can just say 2 pi over 3, it's the length of the circle. It's something tied to the measurement of a circle, the measurement of the arc, measurement of the circumference. This is why radians are much more beneficial, particularly in calculus, because these are actual measurements that mean something. So obviously you're not going to want to do this every single time. Every time you want to convert between radians and degrees, there's got to be a much easier way. Here is a nice formula that you can know. If you want to go from degrees to radians, okay, you can go this way to work out degrees to radians or radians to degrees. You want to go from degrees to radians, you times by pi on 180. You want to work out degrees, you times by 180 on pi. Okay, so I'm going to go through a few problems with you now. We're going to work out in radians. Work out the following. Question 1, I want you to work out for me 30 degrees, 225 degrees, and 310 degrees. All in radians. Now the first one, you can recognize in very nice, neat way of doing this. You can say if 180 degrees is the same as pi radians, Okay, we can do direct proportion. How much is 30 degrees? Well, 30 degrees is just a sixth of 180 degrees. So we can simply say it's pi on 6 radians. So this is the same as pi on 6. Now what about 225? That one's a bit more difficult. Well, you can recognize 225 is a multiple of 45. 45 times by what gives you 225? Well, 45 times 4 gives you 180. You do another 45, that's 225. 225. And again, we recognize that 180 degrees is equal to pi radians. That means 45 degrees is a fourth of this. It's pi on 4 radians. And we realize that to times 45 to 225 degrees, it's the same as timesing by 5. So 5 pi on 4 radians. That's how you work out this value here. What about 310 degrees? Well, 310 degrees, I realize, is a multiple of 30. If I want to work out 30 degrees, that's the same as pi on 6 radians, because we just worked it out in part A. And to get to 310, we can realize, actually, I'm going to change this question from 310 to 330. So 330 is a multiple of 30 degrees, apologies. So we can work out, if we want to times 30 to 330, times it by 11. So it's the same as 11 pi over 6 radians. That is equal to 11 pi on 6. That's how you go from degrees to radians. Now let's go through radians to degrees, which in my opinion is much more simple. Okay, we're going to do these problems here. Work out for me 3 pi over 2, 4 pi over 3, and minus 2 pi on 3. Okay, easiest way to do this, to go from radians back to degrees, is you can say pi radians is the same as 180 degrees. Obviously, I said that before as well, so how is that going to help us here? Well, let's have a look. We can replace pi here with just 180 degrees. So in other words, what we're really doing here is 3 times 180 degrees divided by 2. Now I can say that 2 and 180, they cancel out to get 90 on the top. They cancel out to give us 90 on the top. Then what is 3 times 90 degrees? Well, that's the same thing as 270 degrees. So this is the value of 3 pi over 2. In my opinion, much more simple. Try the next one by yourself. Okay, 180 degrees. So this is the same thing as 4 times 180 degrees divided by 3. Well, we can cancel out the 3 and the 180 to give us 60 degrees. So 4 times 60 degrees. 4 times 60 is 240. Wow, how straightforward. Last one, negative 2 pi on 3. Well, 2 pi is simply just, you guessed it, 180 degrees divided by 3. Now, divide 180 by 3, that gives us 60. So 2 times 60 degrees, that gives us, you guessed it, 120 degrees. Well, in this case, negative 120 degrees. And that's how you work out radian measures from degrees, degree measures from radians, and what the hell a radian even is. It's tied to the measurement of a circle. That's why it makes it so useful for us in mathematics and especially calculus.